making yourself ready, I'm going to give a bit of background. So the talk today is developing WebAssembly UDFs for in-database machine learning. And we have Akmal Chaudhri to talk through this. So a few words about Akmal. So he helped build global developer community and raise awareness of technology through presentation and technology writing.
Hey.
You have over 25 years of experience in IT, and you've done, oh my God, developer, consultant, product strategy, evangelist, technical writer, technical trainer for a lot of blue chip company and big data startups. So please give a very warm welcome to Akmal, please.
Okay, thank you. Okay, any Alexi Sale fans? How you diddling? Okay, you guys are young. Okay, so, all right. So 25 years is a lie, actually. I'm older. All right, but it just kind of sounds nice. One of the observations that you, as I said before, you're all very young. So if you've been in IT as long as this is what you end up looking like. Okay, fat and grey, and looking forward to retirement. That's a kind of nice thing about getting old. So I've kind of worked in database technology a very long time, and so one of the things that you tend to see over time is what do they call swings and roundabouts, okay? So things that were kind of popular a long time ago come around again. And so this kind of concept is nothing particularly new, right? The basics of this have been around for some time. It's just that now we've got a lot of industry support for this, okay? So in terms of drive and support from the large vendors, the likes of Google, Microsoft, and others, okay? So WebAssembly, Wasm, is something you may have come across. And so we'll drill down a little bit deeper, okay? So broad industry experience, as you see the bio, I've been there, done that, got the t-shirt. Worked with various technologies over the years, principally database systems, but in the past it used to be C, C++, did some Java as well. Client-facing roles as well, which I like, because I'm a firm believer that technology shouldn't be used for its own sake, or just because it happens to be interesting. There are business problems that people have for which you're trying to apply the technology and help them achieve, get some solution. And therefore, one of the things that I'd be very interested in is that for you guys, we can network at lunchtime, for example, just come and have a chat with me. So if there's things that you're kind of working on for which you think this concept of Wasm, WebAssembly, might be interesting or might be useful, let's discuss it, okay? Publications and presentations. So I don't have the track record of our previous speaker in terms of publishing and presenting, but I was very fortunate to work on a whole bunch of books over the years. Please don't buy any of these, okay? They are out of date, gone, all right? So it's like technology comes, it's popular for a little while, and then it kind of goes away. Something else comes along to replace it. So database systems, go back in time, years and years ago, object orientation, OO, analysis and design, and then subsequently people applied it to database systems as well. That was the hot technology around about 20 sort of odd years ago, late 1980s, early 1990s. 10 years later, it was XML, that was the hot thing. Anyone know what's hot today? What's the big thing in database systems? NoSQL, yeah? Cassandra, MongoDB, those kind of things. Well, there you go. They'll go as well soon. Yes. Distributed SQL. Yes, that is something that you're seeing a number of companies developing, of which Single Store, my employer, happens to be one of those as well. Yeah, that's right. So one sort of key observation here as well is that, again, things seem to come around and go around, swings and roundabouts, as they say. So over time, what tends to happen is as new technologies kind of emerge, there is an incumbent. And the incumbent, in most cases, tends to be relational. So you see the kind of same arguments that tend to come around. They'll say, oh, relational cannot do this, it cannot do that. You have to use this hot new technology as a way to solve your business problems. And the relational guys, I mean, they are very savvy because they realize that, yes, there's some good innovation there, so they tend to tell their customers, wait, we will add these capabilities and features, you know, give us a little bit of time, and then you'll get these kind of support. And that's what's tended to happen with a lot of this stuff. So objects, XML support has been added over time. Okay, pause there for just a moment. Okay, so there's a couple of deliberate pauses there and a couple of ones that are much more designed around the specifics we're going to do. So if you're interested, I do publish stuff. D-Zone is my favorite place, simply because I have a good relationship with them. The last set of articles, I guess the last 5 or 6 that I focused on, focus very much around data science, machine learning, and sort of applications of how you can use some of the capabilities of database systems to achieve problems that you know, typically may be a bit difficult to solve otherwise. There are some nice kind of capabilities, and it's not just Python, okay? So I've used R in the past as well, and I like it. It reminds me very much of SQL, extremely powerful. One line of R code can do an awful lot, you know, slice and dice the data. So that is something to think about, okay? So if you're interested, okay. Back to the slide deck. All right, so Wasm, this is what you're here to learn about. WebAssembly, okay? Hot topic. How many of you are data scientists? Okay. How many of you want to be data scientists? Okay. How many of you are just developers? A few of you, all right. And the rest of you, hopefully you're here to, okay. A few of you, okay, full stack. They get you to do the work of about 3 or 4 different people, okay? Yes, but you don't get the pay. Yeah. It's a lot of work, and you know, you have to learn a lot of technology. So this kind of stuff might be very useful for you. But equally, the thing is that where Wasm has come from is as a way to kind of not necessarily replace JavaScript, but as a complementary technology, something that can help. Okay, it can do some other stuff as well. Part of the reason for its popularity and sudden rise that we've seen over the recent past is that it's sandboxed. Okay, it's safe. This is something that has really attracted a lot of people to use it. You can get very fast performance as well, near native speeds. Okay, not quite achieving native speeds. There are reasons for that, obviously, because you know there is a virtual machine there as well. And if you are strictly focusing on the front end, all the major web browsers support it. Okay, so you've got no problems. You can get started today, and you can start building and using it straight away. So my kind of interest is really in that last space there. Now, I'll see if I can, let me have a look. See if this is going to work. It may or may not work. No. Apologies. I'm mouseless, so that's the problem that I got there. Can't use my arrows, can't use my boxes. Sorry about that. But currently, there are a couple of vendors that are really taking Wasm in the direction of database systems. So there is an opportunity now to say, well, okay, maybe you've developed some code in the past in C, C++, Rust, okay? Other languages are gradually coming along, but those are the 3 that seem to be the most popular and the most well-supported at the moment. And we can convert them to Wasm, a binary format, and we can execute this code now in the database system. So think about that. That's a great example of reuse, that maybe there is some existing code libraries or things that you've developed in the past or other developers have built, and now there's an opportunity to continue utilizing those and getting some value out of that and using the power of the database system to execute that code. And we'll look at an example or 2 of that very shortly. The other thing, serve as a universal compiler target that can run in a browser. Right? Like I said before, that's really where the emphasis has been. Does not require garbage collection. Now, think about that, okay? There are some issues associated with that, then, okay? So certain languages, then, it's going to be a little bit tricky and bit difficult to support. So, but the thing is, there are efforts underway in that space as well, all right? Nothing immediate, but give it time, and those things will come along. You get type and memory safety as well, which is, again, great. And as I said before, you know, if you are working on the front end with JavaScript, it isn't necessarily an entire replacement for it, rather complementary technology, and you can use it, you know, together. Currently, backends exist for a variety of languages, of which Single Source, the company that I happen to work for, is supporting C, C++, and Rust. Other stuff is in the pipeline. There is an excellent website. Sorry, it's a little bit dimmed out there. Let me just share that with you, okay? And just to show you what's actually there. Let's take a look at this. Okay, so this is on GitHub. And let me see if this will work. There we go. That does work. Awesome Wasm langs, okay? And so this is a very nice website because essentially there you can see huge list of languages, even the likes of COBOL. No COBOL programmers here, okay? Yeah, a couple of years ago, I read somewhere, or someone told me, there's more lines of COBOL code in the world today than everything else put together, every other programming language put together. Problem is there's not an awful lot of new COBOL development, okay? Mostly it's maintenance of existing code, but you know, very verbose English-like language. But there you can see, I mean, there's huge effort there. And unfortunately, the quality of the support is variable as well. So some languages are much better supported than others. I mean, that's the nature of life. Even in the open source space, for example, you'll see some projects are better supported than others. But there we go. Okay, all right, so we've done that. Okay, so if we were interested then in applying and taking some of these sort of code that we previously had executing outside of the database system, what are the sorts of things we could do? Well, fuzzy text matching, for example. Pushing the actual application logic down into the database system. This concept of co-locating the data and the code that executes on the data together. Right? There's no need to have them running in separate environments. Neither do you have separate sort of processes, if you like, to be able to do that. Other things, simple things, finding top 10 highest scoring records against machine learning model in a single SQL statement. Mathematical operations, in finance, for example, matrices, vectors are very often used. Interestingly, Single Store actually supports some vector operations already. And you can do things like Euclidean distance, for example, very easily. But you could extend those capabilities. Maybe there's other things that you want to utilize, and you can do that there as well. Okay. So as far as the database system is concerned, then we have essentially this kind of sandbox that is residing within our DBMS service. Whatever the source language is, okay, and again walk you through a couple of examples there. We'll do a C example, and we'll do one in Rust just to show you how this could be done. And then essentially we just load this into the DBMS, and then we can just call it like a regular UDF, okay? All right, so let's actually get on and take a look at an example. If you're interested and you'd like to get started quickly, okay, there's a couple of places you can go. So the best place to go, let me just see if I can do this, whether it's gonna, it doesn't like that. Perhaps we can do it from here. There we go, okay? So GitHub, Single Store -labs. All right, so that's the GitHub repo. That's the top-level repo. And if you just drill down in there, you'll come across a couple of things. There's a Wasm toolkit, okay, and also a tutorial which effectively kind of mirrors what I'm just going to show you here as well. There's two examples that you'll get to see. This x to the power of y, okay, very simple one, and a bit more in terms of string and how we can split strings up and so on, okay. And then at the end of this presentation, I'll show you a little bit of sentiment analysis as well, so using something called Veda, okay? That is an actual example. And again, more details on the GitHub repo if you are so inclined and you're interested and like to try that out for yourself. Okay, so we've done that. All right, so those of you who've been around for quite a long time, you may have come across this concept of, interface definition language, IDL. This is not unique to Wasm. If you've worked in technology such as Corba, for example, Common Object Request Broker Architecture years ago, they had something very similar here. So it's an example, and I'll show you a little bit of code shortly, of essentially we define what is the interface in a sort of fairly neutral way, okay? And then what we can use that as the basis for generating the actual code that we want. There's a bunch of supported types. Okay, you can see there's some stuff that's missing from there. Again, it's work in progress. And then essentially what we do is we take this IDL, we run a code generator across it, we get this thing called a WIT file, okay? And we'll look at that very shortly, okay? So let's work through two simple examples, okay? Same bit of code, or same problem, okay? X to the power of y. And then we'll work through an example using C, and I'll show you the generated code as well, okay? And then we'll look at an example using Rust, just to sort of compare and contrast them. So we'll create our WIT file. We'll get some source code, okay? We'll compile that to this binary format, Wasm. And then all we can do very simply is we can load this into the database system, and then we can just run it as though it's a standard piece of SQL UDF, okay? And then just get some results back and be able to execute that. All right, so let's have a look at that. So can you see here then, the very first step then is to create our WIT file, this interface, if you like. So we're defining this power of, we've called it, okay? It's a function. It takes two parameters, two signed 32-bit integers, okay? The base and the exponent, you can see there. And then what is the end result? It's also a signed 32-bit integer, okay? So this is the definition that we're going to provide in our WIT file. There is a tool chain, an SDK, some stuff that you have to install, okay? I haven't shown it here, but again, all the instructions are on the GitHub repo for single store. It would tell you what you need to install in order to achieve this result. And then we just simply say, okay, C is the target language, take this power.wit, okay, and generate me the C code. And from that, what you'll get is the header file, .h, and you'll get the actual C file as well, right? So what this will do is it will give you the framework, if you like, the plumbing, the infrastructure. What it won't give you is the actual code, because it doesn't know what you're trying to do there, right? It knows the interface. Now it's up to you to add the code in so that you can actually generate the Wasm file, okay? So again, I'll show you that very shortly. So the .h file gives you the prototype. Can you see the similarity between that and the IDL itself? Okay. And then within the .c file that's generated for you, there's a whole bunch of other stuff in terms of allocating memory and freeing memory. And like I said before, I mean, it does the infrastructure, the plumbing, and all of that for you. Now you have to provide the implementation to actually say, well, this is how we achieve the thing that we are trying to achieve. Okay. And then there's the code that will give us this result. X to the power of y. Once we've done that, again, we just take this and say, okay, we want to generate a binary from this. The target is power.wasm. Okay, take power.c as the input. It's just a command line thing, okay, and we get the end result from that. And then once we've achieved that, we've got two things that we can use. We've got our WIT file, okay, which contains the interface, and we've got our Wasm, which is the binary. And now what we can do is we can tell the database system, please create a UDF for me, create function, give it a name, and you can see slight extensions to the SQL syntax there, and we'll say, okay, now in this case, can you see we're using infile, which is kind of local. It's hosted locally, all right? More about that very shortly. So essentially just provide the path to where the binary is, provide the path to the WIT file, and it will create that UDF for you. And once you've got that in the database system, now you can just execute it like any standard piece of SQL UDF. So you can just simply call it like this, select power of, okay, pass it the two parameters there, or you could do multiple calls as in the second example there, and that would just execute as though, you know, and you get the result shown like this, okay? So for example, 2 to the power of 8, you would expect 256 as the answer, okay? Very, very straightforward. So, yes? This, I think, is specific to this implementation. How other vendors do it, I'm not sure. But yes, you've got... Yeah. Yes. Yes. Yeah. I think the thinking with a lot of this stuff is try to keep it as similar as possible to what's already been done. That helps you guys, because otherwise you're faced with a kind of a dilemma in terms of having to learn a new language, new syntax, and a new way to kind of do things. So yes, one observation, if I could just add from my own experience over time, is that unfortunately, you guys, you're faced with a terrible challenge today in terms of the amount of technology and the number of different packages and frameworks that you have to learn. And if anything can be done to make your lives easier, I think that's got to be a good thing. All right. Quick review of the Rust example, and then I'll show you some of the code. So again, can you see the IDL exactly the same? This is the width. In this case, because we are working with Rust, slightly different, cargo init, okay, VCS, none, lib, that gives us a source tree of sort of framework. If you work with Ruby and other languages like that, for example, you get this directory structure and all sorts of other things as well with it. We have to provide some details about dependencies and other things like this. So we do this inside this cargo file. Okay. As part of that, again, it generates a directory called source, okay, with lib.rs. That's our Rust code. And now, again, as with the C example, it's up to us as developers to provide the actual implementation. So it's happily done everything else for us, but because it doesn't know what we are trying to do, it's our responsibility to provide the actual code that produces the result that we are looking for. So there's the kind of the Rust equivalent of the C that we were just looking at a few moments ago. And same thing, then we just do this cargo build. Okay, again, we provide it with a target here, slight difference in syntax, and the rest of it is identical. Essentially, then we just create function, again, provide the path to where the Wasm resides, the binary file, where the interface definition is, the width file, and we use it exactly the same way. Okay. So 2 different ways to achieve the same result. Again, depending on what your preference is, whether you happen to be a C or C++, maybe that's perhaps your particular strength, or you're working with Rust, you can use either of these to achieve exactly the same result. Okay, so now I do have a demo there in terms of sentiment analysis, but let's just take a little bit, see if I can just try and get in here. Let's have a look. Now, are these large enough? Well, large-ish. I'll see if I can make this a little bit bigger here. Okay, like so. All right, so that's currently running Jupyter, but what I want to do is have a look here. All right, so this is a work directory. I suppose the font should actually be changed, but let's just make this a little bit bigger here. Okay, and maybe even bigger, like so. Okay, so here's an example with the Rust. Okay, so there you can see the width file here, and this is for the sentiment example that I'm going to show you. But let me just go back, and we'll have a look at the power example. Okay, so this was the C. So it generates the power.c, the power.h for me, and we can have a look at these quickly. Oh, sorry, my bad. There we go. Okay, so this is the prototype that's generated. There you can see down at the bottom there, the int32 power, okay. And here's the C that's generated for it. Again, if you look at the top there, you can just see where it says canonical ABI free, okay, in terms of memory management. Thank you. Okay, and then the actual implementation of the code down at the bottom there. That we have to provide that, okay? The rest of it is done for us. And then you can see here, because of the way that this particular example works, the binary is right at the bottom there. The power.wasm sits in the same directory. Very, very straightforward. Slightly different for okay, let me just do this. Slightly different for the Rust there. There's a bit more that's generated for us. Okay, so again, the power.wit resides in the root directory there. we've got the cargo file that I showed you a few moments ago, source directory. Okay, and there's the there's our implementation, okay, that we provided in terms of how we actually want to achieve this x to the power of y. And subsequently, in terms of target then, I mean, there's a lot more that is involved with, a lot more that's involved in the Rust. So we get a target directory and a whole bunch of other things below that as well. But I think, okay, cd debug. Okay, there we go. There's the power.wasm, if you're able to see it right at the bottom there. Okay, there. That's it, okay? So I'm loading this in and doing that create function. Obviously, in this case, the path is going to be a little bit longer, but you can move this code around, I mean, wherever you want to in terms of creating the UDF. That's no problem, all right? So two different ways, as you can see, to achieve the same thing. All right, so the sentiment analysis then. So let me show you an actual sort of machine learning sort of problem, if you like. So this is using something called VADA. Some of you may have come across this, okay? Valence-aware dictionary and sentiment reasoner. Lexicon, rule-based sentiment analysis tool, interpret and classify emotions. Hard problem to do, emotions, right? Thing is that this can handle things like exclamation, for example. So we may want to emphasize something a lot. For example, we might say, oh, the food was really awesome, exclamation, 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 okay? It kind of weighs that as something then a lot heavier and more meaningful. Capitalization, right? Generally, as you know, that's kind of frowned upon on the internet and Twitter. It's like you're shouting or something, but maybe you want to convey some real strength of feeling to say, oh, I really like this food, you know, it was excellent, for example. And things like emojis as well, okay? It can utilize that. So this is, again, a GitHub project, part of a research paper that goes with this. This has got nothing to do with, you know, the WebAssembly per se, but this is what we're going to use in terms of generating and doing a bit of sentiment analysis. So it's actually implemented in various languages. Originally written in Python, but it's available in Rust and Java and some other environments as well. Okay, so have a look at that. And so what it does, we have this function, sentiment intensity analyzer. It takes in a string, so we might say, for example, you know, the food was awesome, but the service was terrible, for example. It might take that as a string parameter. And then, based upon that, it will give us some scores. Does it come across as particularly negative, for example? Is it neutral? Is it positive? And then compound is normalizing the score between -1 and +1, okay? That's what it does for us. So this is just taking some parameters and then just delivering some results for us. And again, we're just going to utilize this code that somebody else has provided in terms of a library and just build a Wasm model from, module from that, okay? So following the code, the Rust kind of example that we talked about a couple of moments ago, done exactly the same here. Okay, let me just go back here. Sweet. I really ought to learn how to type. There we go. Okay, so we have this thing called this sentiment table.wit we've created. Let me show you what that looks like. All right, so here you can see we've provided these polarity scores, as they're called. We've said what's the input to this function, it's a string, and what is the output that it produces these polarity scores for us, okay? And then just following the sequence of steps that we did earlier, again, running the code across this, we get source, okay? Let's have a look at this. Okay, now here, as you can see, there's quite a bit more code involved, but it's not too bad. There's not a huge amount. So the polarity scores there, so there's the implementation. And there, if you look at the code there carefully, you can see we've got this sentiment intensity analyzer. So this is basically just utilizing something that somebody else has written. We're not having to implement that ourselves. We're just calling that as part of this environment, and then we're just getting these results back, okay? It's as simple as that. So once this is done, just minimize this, okay? And let's take a look at the, I think it might be, let's have a look. All right, there we go. Let's just make this bigger. And we'll take a look at this. All right, so this is just a MySQL client that I've got here. I've got a very tiny 2-node cluster running on this laptop. Okay, so one is kind of like the master aggregator. The second node is just holding the data. I've loaded in data. Thank you. This is from Stack Overflow. Okay, so these are comments, and it's about 20 million rows. Previously, I've got these functions here as well, if you look carefully, that I've loaded them in. I could call these now directly if I wanted to. All right, but what I think is a better way is simply to fire up Jupyter. Okay, and we can connect to this cluster, and then we could run a notebook from here, and we can take a look. Okay, that's a little bit easier. All right, so again, let me just see if I can make this. Make it a little bit bigger. Should be a little bit easier on the eyes there. So standard kind of stuff. Okay, we're going to do a little bit of plotting there. So we just import Plotly. And remember, you know, there are multiple kernels available for this environment. This just happens to be Python, which is a little bit easier. I like it, you know, but Java is available and other things as well. So we'll just execute this. Okay, that's done. The second one there is just calling some setup information. Okay, so I'm just providing some connectivity information. Where is the, you know, what's the name of the host, what port, and so on. What's the password? And it's just picking that up. Okay, and then just below here, again, what we're doing is simply setting up the connection information there to our host and port and so on. So all of this is really nothing to do with the example there. But now, here, we can take a look at you know, how many of these do we actually have resident. So I've run this previously. Okay, so as you can see, it's about 20 million rows, and we can take a look at some of those here. Okay, just execute this. Let me just do this again. Okay, and if you look at that carefully, and if you've got sharp eyes, you'll see. I mean, it says, "Isn't the desired result supposed to be blah blah blah?" Yay, sorry, I forgot to rebuild. I used the case overlay template. Thanks, Jason, so on. So, Stack Overflow, okay, comments from users. And what we're trying to do is we're going to try and pick up some sentiment from this, see if we can get something meaningful from this. So, the Wasm created, that we created, okay, we've just loaded that module into the database system. You saw that just a couple of moments ago, and then we can just execute that. Okay, and in this case, we're just passing in read the docs. Okay, so there you can see it's given a score of neutral. There's nothing particularly strong or weak about that, but I could try something else instead. Okay, so I could say the food was awesome. Okay, we'll put a bit of capitalization there. But the service was terrible. Okay, let's just see what it makes of that. So there you can see slightly different result there. Compound, positive, negative, neutral. It's slightly different now. Okay, and then again, if you were to change that text, say I had awesome in lowercase letters, that weighting would be different. Again, it's pretty smart in terms of how it evaluates that. And then the last thing down below here, we've got a fairly hefty SQL statement there, which utilizes that Wasm binary to execute some detailed analysis. And that, again, that's on the GitHub repo. Okay, let me see. Has that finished running? It's just running there. As you can see, I've got it. It's finished. And we can take a look at the sentiment scores there. Again, it's done a bit more of a sort of thorough analysis for us. negative, positive, that's all we're interested in, not so much the neutral. And then what we could do finally is plot it. So as the previous speaker was saying, visualizations are wonderful. I agree. And this is just ordinary least squares, as you can see, based upon that 20 million rows. We just plot it, and this gives you a slightly kind of visual in terms of the results. Okay, so we are done. And the last slide here, well, just finish off there. So you saw me using in-file. Now that's a little bit inconvenient because that means you have to build it and store it locally. Actually, you could put it anywhere, on an S3 bucket or on Google Cloud, wherever you want. There's just an example of how you could do this. Very easy. You could do the same thing. Okay, load it in. So WebAssembly, Wasm UDFs provide great power, extensibility, gives you a lot of flexibility. Now you can utilize existing code that's been written or bits of code that perhaps you want to store it and use it in a database system that might give you a bit more sort of power and oomph. Extend the system in C, C++, Rust. At the moment, those are the three languages that single store supports. Other languages in the pipeline, fast, safe, okay, because of the sandboxing. This is one of the reasons for its popularity. And I think this is going to have a lot of impact in the coming sort of months and years as well. And just to be fair, so single store is one of just a handful of vendors that is developing this specifically around the database technology space. So if you are working with ScalarDB, for example, which is a NoSQL Cassandra drop-in replacement, they are also doing something similar as well. And I think there are one or two other vendors as well. But none of the big guys, the Oracles, the Microsofts of this world, yet are there. So this is available, okay, and there we go. Right, and so I'll be around, okay, so come up and have a chat with me during lunch, okay, and if this is something that you think might be interesting. If you want to get started on this, there is on the GitHub repo, it shows you how to use Visual Studio Code. There's a dev container, okay, you can use. Get started on it straight away. I've shown you very much kind of a manual, step-by-step, do it by hand type of thing. Actually, there's an easier way to do it, okay? But I wanted to show you this way to actually show you the steps that would be involved if you wanted to do it that way. All right, guys. I realize that I'm all that stands between you and lunch, so we'll wrap up there, I think, because I'm out of time. But again, happy to take some questions outside. Yeah, okay, so I'll be around.
A little bit of time for question.
Okay. Great, yes.
I might have a question about the sandboxing that you guys have at single store.
Yes.
Is it something that can be explored at the research level without licensing?
No. So that's a great question. The question is really asking about the sandboxing, okay? So the virtual machine is run within the DBMS environment. The Wasm itself is not unique to a single store. I mean, you could take that Wasm, you could execute it somewhere else if you want. Okay, so all of the steps I've shown you, the code is entirely independent of the platform. The binary is independent of the platform. Again, it's that, I mean, it was a bit of a joke. I mean, write once, run anyway. I mean, Java used to have that. Now you can truly achieve this with Wasm, with WebAssembly. So everything that I've shown you, yes, there are some extensions that you've seen to the SQL syntax and the ability of the system to take the UDF, store it and run it. That is proprietary to single store. But the thing is, the Wasm is totally, it's independent. It's got nothing to do with single store. Neither has the WIT. These are standards by W3C, and the Bytecode Alliance is the organization that's non-profit that's helping to drive this awareness. Yeah.
In AWS, I have a problem.
Yeah.
I need to find for a trading arbitrage scenario a solution to the data science, machine learning story in real time, close to real time. So I know all the technologies that I've been working in the past, they're not good enough. The ones the JVM plays in Python, UDFs, it's not good enough.
Yeah.
How performant it is single store in like an EC2 box that you can buy? How performant it is for a scoring capability? Can I go do a round trip on scoring on like 40 milliseconds?
That's a great question. So the question there is asking really about performance and the ability of the company that I happen to work for, Single Store, how well and how performant could something like this be. What I could say to you is the product itself is a distributed SQL system. Obviously, now the thing is that the Wasm itself is a black box. Okay, we can't look at the binary code. There are other optimizations that we could do, but there's nothing to prevent you from running multiple copies of that on different parts of your data set. The system also provides streaming capabilities. So for example, it can read in from parallel, from S3, for example, or Google Cloud or whatever. It can work with Kafka as well in terms of streaming. Again, what I'd recommend is that if you have time, just take a quick look at some of the articles that I've done on DZone, because I've described some of those scenarios. How can we ingest vast quantities of data in quickly? And so the ingest is no problem. The system can, yeah. 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 Right. We can have a chat offline. I think that would be great. I mean, we can follow up with you. But what I would say is that we've got customers like Thorn, for example, who do image. And this is very important because they are dealing with kids, for example, who are being trafficked. And therefore, it's very important to do very fast image matching. And so that is milliseconds. Okay, I mean, you're very, very fast in terms, because it's a life or death kind of situation. Yeah. 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 Great. Any other questions? Yeah, yes, question.
Yeah, in one of the earlier slides, I'm pretty sure it was mentioned about fuzzy search. Fuzzy search?
Let me just stop me for this slide, okay? Just go back a little bit. I think, was it here? This one? Fuzzy text matching?
Yes.
Yes.
So is this a feature which is built in single store, or?
Not per se. Okay, so the question is asking really about the fuzzy text capability. So I think what this is trying to allude to is that if you have got some fuzzy text algorithm or you've got some implementation, you could convert that to a Wasm module, have single store execute that for you. That would probably be a lot easier. Whilst the system does support some things like vector and matrix and other things as well, nevertheless, there may be some extensibility that, you know, as is typical with a lot of database systems today, there's things that they don't do out of the box, but you can extend them with this capability. I think that's the point it was trying to draw. Great. All right, guys, great. Well, have lunch, okay, and grab me during lunch then, okay, and then we'll have a chat. Great. Thanks very much for your time.
Thank you very
and your
much.
attention.
And we'll be back
Have a
at
great conference.
1:15.